Okay, hello everyone. Welcome back. We're going to be doing another live stream on basically picking up where I left off. Last time I was doing a GraphQL tutorial on this website here, how to GraphQL. We learned basically some of the concepts, the relationship between the clients and the servers, mutations, queries, all that kind of stuff. But the next step is to do something practical. So I decided I want to do a full stack project. So I'm going to be starting just by following their tutorial, using the GraphQL Node tutorial here. And then eventually I'm probably going to switch to a front end piece once I finish this project. And we're going to be using React and Apollo for that. So that is what I'm doing. Okay, let me just make sure I got everything. My containers set up. That is good. Okay, so let's just start. So I'm just gonna maybe skim some of this, maybe just read it out loud to you. You guys can follow along. And by the way, if you're trying to replicate this setup, I'm using a Docker development container that allows me to just basically access a Ubuntu box. I've found that being on Windows for this machine, I usually have problems trying to set up projects, so I've just ended up creating a developer box or developer environment that gives me access to everything that you would expect on a Ubuntu machine. So that's what's going on in my PowerShell down there. Anyways, and if you guys want to know how to do that, let me know. I can show you how to set that up. I actually may create a video on it because it's a pretty useful thing. Anyways, all right, so GraphQL Node tutorial. GraphQL is the rising star of backend, replaces REST. We're going to create a GraphQL server entirely from scratch. Apollo server. Okay, fully featured GraphQL server. Use Prisma client. Just move this stuff to the side here so I don't get distracted. Okay. Okay, so Prisma is an ORM. GraphQL Playground, a GraphQL IDE that allows you to interactively Okay, so similar to Postman. Oh, okay, I think I've used this before. Auto-generates documentation, provides an editor, auto-completion, syntax highlighted. Okay. You're going to start by learning the basics of how it works. We're going to be building a Hacker News clone. If you guys don't know what Hacker News is, it's this. Basically a Reddit clone. But, there's different posts here. You click on one of these things, you can go to the link. You click on comments, you go to the comment section, and then people are talking. So that's kind of what we're doing, or what this project is for. Or to build something similar to it. We're going to build the schema and the resolver functions. Stored in memory, so nothing will persist beyond the runtime of the server. Okay, we'll be using SQLite, and we're going to be accessing it with Prisma. Sign up and login functionality that enables users to authenticate against this API. Allows you to check the permissions. Okay, that sounds good. Yeah, I've kind of been through here. I was just kind of setting it up earlier to make sure everything worked. But okay, so I already have a directory for this, the Hacker News node, which is over here. And this is where my project is. And this is just an empty project. There's nothing in here right now. So let's actually just set up a npm project here. And we should have a package JSON, which we now do. Good. That is huge text. Holy smokes. Okay. Create a new directory called Hacker News Node. Initialize it with package JSON file. Okay. List all dependencies. So creating a raw GraphQL server. With a project directory in place, you can go ahead and create the entry point for GraphQL. This will be called index.js. Okay, let's do that. So we're going to create a directory called source. And we're going in source. And now we just want to create index.js. And we should have this refresh here. There we go. Do I have to set this up for Node? I know I usually have to do this for Java, like mark directory as source or something. Okay. I don't think I have to do this for a Node.js project. By the way, I'm using WebStorm over here. This is the editor that I'm using. Okay. To start the app, you can execute node index. Right, so this isn't going to do anything. Oh, okay. Run the following command in your terminal. And okay, so we're going to install Apollo. Let that go. Wish I had faster internet, but it is what it is. While that's happening, let's take a look at what we're going to be doing next. Apollo Server is a fully featured GraphQL server. It's based on Express.js and a few other libraries. GraphQL spec compliant, real-time functionality with subscriptions, out-of-the-box support for GraphQL Playground, Express middleware, custom directories, query performance tracing, runs everywhere, can be deployed via blah. Okay, that's pretty convenient. Open source index and type the following. Okay, so this finished now. And now we have our Apollo server here. So I'm actually going to be typing everything out because that's the best way that I learn. Some people can copy and paste this, but that's what I'm doing here. Apollo server. Okay. So let's create the type. String. I believe this means required, if I'm not mistaken, from last time. Okay. Equals. Yeah, I was going to use AppSync, but I want to learn the basics first before I go into something. Okay, the problem with AppSync is that it hides a lot of the complexity from you, and I want to understand how it works first before I use something that makes my life easier. So that's my rationale. Like once I figure this out, then I'll probably start using AppSync, but I just kind of want to like learn the basics before I do that. That's my answer to that. Const resolvers. Query. Info. This is the API of a Hacker News. I don't know why I'm so tired today. And then we just pass in type defs, right? Okay, and then we're going to start our server. Oh, I think I need to like, I think by default it runs on some other port, so I'm going to have to look up the documentation on how to fix that. What is happening here? There's so many brackets. So that. Is that right? Yeah. Fat arrow. Syntax error somewhere. Oh, that's why. Okay. What are you complaining about? No, I don't want to do that. Okay, let's just take a look. So we have our type defs. Okay, we have our import, we have our types, resolvers. Okay, and we're passing in our type definition and our resolvers. And then we are listening on this port. Good. Okay, what did I say I need to do? So my Docker container here only exposes port 3000 and 3001. So I believe if I just run this right now, it's going to run on a port that I don't have access to. So let's see what happens. Okay, so this is localhost for the Docker container, which isn't actually where I can access from. So I need to go to, where's my IP here? Give me a second. Right, so I need to find how to override the port because it's on 4000. And so what library is this? Apollo server, right? So Apollo server override port. All right, I have everything like super zoomed in right now. Port, here we go. Oh, okay, you just pass in port. Port 3000. Comma. Oh, needs an object. Derp. By the way, I'm using Vim, which, if you don't know, that's why I'm like jumping around and doing weird keyboard things. Okay, so we can kill that. Start that. Okay, so now we're on 3000. So this should work now. Boom, okay. Let me keep that tab open. So that's my local IP, just on my network. And so this is the Apollo playground, apparently. And so let's see what this thing is telling us. So we're testing the server. We're able to start it up. That's perfect. Everything's working so far, so good. Hold on. This is just describing what we just did. I kind of want to go over this. Indicates into which file you need to put the code. Okay. The type def constant defines your GraphQL schema. More about this in a bit. It defines a simple query with one field called info. One field called info. Field has a type string. The exclamation mark in the type definition means that this field is required and can never be null. Okay. The resolvers object is the actual implementation of GraphQL. Notice how it's structured identical to the structure of the type definition inside type def's query info. So it's not taking a string though. This is passing in a string, right? Shouldn't this have like something in here, you know? Maybe I don't completely understand the notation yet, but we'll get it. The schema and resolvers are bundled and passed to the app Apollo server, which is imported from Apollo server. This tells the server what API operations are accepted and how they should be resolved. Okay, we already did this. We got our running server, and now we are here. By clicking the docs button on the right, you can open the Apollo API documentation. The documentation is auto-generated based on your schema. Okay, that's handy for this stuff to be auto-generated. So I think it's saying, oh, okay, cool. The string scalar type represents textual data. This is kind of neat that it does this for you. What is this? Don't know what this is. Okay. How do I make this go away? There we go. Okay. So we got that running. Let's go ahead and send your very first GraphQL query. Type the following into your editor pane on the left side. So query info. Hey, it worked. Making progress. Sorry. Great to see this happening. Really appreciate the efforts. Thank you. Or, well, you're welcome, rather. Thanks for watching. Okay, let's keep on going. So now send the query to the server by clicking the play button. We already did this, and we saw the same thing, right? Yep. You just implemented and successfully tested your first GraphQL query. Let's go home. Now remember when we talked about the definition of the info string field and said the exclamation mark means this field can never be null. Yes, I remember that. Since you're implementing the resolver, you're in control of what the value for that field is, correct? Wait, so this is the return type of the function? Is that how to read this? Oh, okay, yeah. I think it is. Because we're returning string, obviously, right? So, like if I do, like an, will this blow up something? Let's try. Okay, still working. Oh, it's okay. So it stringifies it. Interesting. All right. Some quirks to be aware of. In index.js, update the definition of resolvers as follows. Okay, so we're setting it to null now. So this should cause an exception. To test the results of this, you need to restart the server. Okay, so this should throw a compile time error, or runtime error rather. Send the query from before again. This time results in an error. Yeah. Cannot return null from non-nullable field. Cool. All right, so don't do that. What happens here is the underlying GraphQL JS reference implementation ensures that a return type of your resolvers adhere to the type definitions in your GraphQL schema. Okay, that's good. Protects you from making stupid mistakes. One of the core benefits of GraphQL enforces that the API actually behaves in the way that is promised by the schema definition. This way, everyone who has access to the GraphQL schema can always be 100% sure about the API operations and data structures that are returned by the API. I think that's true. Like the reason that I like the idea of this is because you define your models here. And this is kind of the documentation of what all your APIs are. So it's easy to share between front-end developers and back-end developers. Like this is your model dev so that you can communicate with one another. A lot of folks, they do this through like other custom-made template files that contain their model definitions. At least that's what I do. But this kind of solves that problem. So where was I? Okay, we got that. There's a GraphQL schema. Be sure to check out this excellent article. Okay, they're written in SDL. We learned about this from our last live stream, just like others. How does this help in defining the API for the GraphQL server, though? Well, every GraphQL schema has this three special root types: query, mutation, and subscription. The root types correspond to the three operation types offered by GraphQL. Okay, the fields on these root types are called root fields and define the available API operations. Consider the simple GraphQL schema. Okay. Schema only has a single root field called info. When sending queries, mutations, or subscriptions to a GraphQL API, these always need to start with the root field. In this case, we only have one root field. So there's only one possible query that is accepted by the API. Got it. So if you had multiple of these, then you can obviously have different queries. Okay. Let's consider a slightly more advanced example. So what are they doing here? They are just comparing it with what we have from here. So they're returning a list of users, right? and it's required. Then they're saying this query takes in a string for the ID and returns user, if I'm reading this right. Mutation creates a user, takes in a string for the name. Oh, I see what they're doing. ID is an object, I think. Because you see how like name and then primitive? Name a variable and then, is this primitive? Or is this defined somewhere? Maybe it will be, I don't know. We'll see. And then type. Okay, here it is, here it is. But don't you have to define this as a type? Like what is ID here? I don't know. Someone know? How do we create routes in Apollo server like we do in Express server to create specific URL for different actions? I have no idea, man. I'm learning this for the first time. So hopefully we figure it out. I'm sure we will. I mean, I can't imagine any tutorial here would not show us that. What are the API operate? Okay. In this case, we have 3 root fields. Users and user on query. Users and user, yeah. As well as create user on mutation, create user. Right. The additional definition of the user type is required because otherwise the schema definition will be incomplete. Yeah, because you're referring to something that is defined down here. What are the API operations that can be derived from this schema definition? Well, we know that, well, I think we just kind of figured this out. You know, you can get all your users, you can get a specific ID of a user, and you can create a user. Let's skip down here. When the type of a root field is an object type, you can further expand the query for mutation subscription with fields of that object type. When the type of a field is an object type, you can further expand the query with fields of that object type. Oh, okay. So that's how it was getting the ID thing. See how it's referring... Wait, hold on. When the type of a root field is an object type, you can further expand the query mutation description with fields of that object type. Okay. Expanded part of the is called the selection set. Here are the operations that are accepted by GraphQL that implements the above schema. This is different than what we just saw, right? Yeah, so this is... Wait a second. Oh, this is... Okay, these are the queries themselves. Okay, I'm sure we'll get to this. Wait, can I run this? Will this work? I don't have any users, but... Not query field users and type query. Oh, it's probably not going to work because I don't have my types defined. Yeah, I haven't defined user or anything. Okay, obviously that's not going to work. Okay, it's probably the next step, so I'm just not going to get ahead of myself. In these examples, we always query ID and name of the returned user objects. ID and name. We could potentially omit either of them. Note, however, when querying an object type, it's required that you query at least one of its fields in the selection set. What if I want the whole thing? Three root fields all have different type modifiers, i.e. different combinations of being a list and are required for the user type. For the users field, the return type user bang means return a list, which itself cannot be null of user elements. The list can also not contain elements that are null. So you're always guaranteed to either receive an empty list or a list that only contains non-null user objects. That's convenient. For the user ID bang field, the return type user means the return value could be null or user object. Oh, because you didn't put a bang here. Exclamation point, which is the force, not null. It's kind of nice that they add that as a first class symbol here. Started raining. For the create username string field, the return type user means this operation always returns a user object. Phew, enough theory. Let's go and write some more code. Yes. What role do the root fields play for GraphQL? Oh man. Root fields implement the available API operations. I think it's this one, right? Yay. Okay. In this section, you're going to implement the first API operation that provides the functionality of Hacker News clone, querying a feed of links that were posted by other users. Querying a feed of links that were posted by other users. Okay. Let's start by implementing a feed query, which allows you to retrieve a list of link elements. Oh, link in the sense of, like, I showed it before, but let's just keep Hacker News up so people can remember. Like, these are links, right? 1, 2, 3, 4, 5. So when it says we're going to implement a feed query, which allows you to retrieve a list of link elements, it's basically saying, like, get all of these 1, 2, 3, 4, 5, 6. And then I'm assuming with like a URL and a name and maybe some other metadata like you have here, right? Comments, time, points, all that stuff. Okay, let's start by in general, when adding a new feature to the API, the process will look pretty similar every time. Extend the GraphQL schema definition with a new root field and new object types. Implement corresponding resolver functions for the added fields. So the interesting part is, like, this is all happening locally, right? I'm just trying to think, like, how is this different than what you would have in production? You would have, well, this is just the server part, but I suppose we'll come to the front end part later. In Next.js, update the type defs constant to look as follows. Okay. Query. So we're going to keep our string for info. And then what? Feed link list. Not a linked list, but a list of links. And then we need to define a type. This happens... And there's got to be a better way. Like, can't I put this in my own file or something? This is just dumb looking. Okay. Don't get ahead of ourselves. I've learned the hard way. So ID. So a link has an ID of a user. It's got a description, which is a string. And it's got a URL, which is also a string. Which makes sense. If we go back to this, we have an ID, which is, I don't know, maybe a UUID or a hash or something. And then a description, which is the line here, which is required, and then a link. So this goes to wherever this goes, PSX party. All right, cool. Pretty straightforward. You're defining a new link type that represents the links that can be posted to Hacker News. Each link has an ID, a description, and a URL. You're then adding another root field to the query type that allows you to retrieve a list of link elements. Sorry, I just want to read that again. You're then adding another root field to the query type. Yep. That allows you to retrieve a list of link elements. Man, I need another coffee. This list is guaranteed to never be null, as we saw. If anything, it will be empty and never contain any elements that are null. And that's what the 2 exclamations are for. The next step is to implement the resolver function for the feed query. In fact, one thing we haven't mentioned yet is that not only root fields. Wait, One thing we haven't mentioned yet is that not only root fields, but virtually all fields on the types in GraphQL schema have resolver functions. Virtually all fields. All fields? So this has a resolver, this, what? Oh wait, I think I remember briefly reading over that when I was looking, when I was doing the first part of the tutorial. So you'll add resolvers for the ID, description, and URL fields of the link type as well. Whoa, that's blowing my mind. So what are we doing here? Okay, so we're creating an entity. It gets confusing when they put it all in one file here. Okay, so links. So we're going to create one of these, right? Something with an ID. This part's confusing me. Anyways, let's just go with it. ID link 0 URL and then what did we say for the resolvers? So we're adding another one for feed. This doesn't take any input, right? Oh, yeah, yeah. It just returns the links. Got it. And returns links. There we go. So we're just returning this thing. Okay. And then for the resolvers. Oh, okay. Sorry, what was I looking at? Link ID parent. Okay, so this is the first part where we finally add the resolver for, I guess, this object. Yeah, I'm just going to type this and then we're going to walk through it. Link. URL. Okay. Let me just go over what I have and then I want to read what they have. So we have a query that is of type feed and returns a list of links. A link is this thing. It's got an ID, which is a type ID, which I still don't understand that part. Like where did the fact that this is a string even come from? I don't know. Description, it's a string required. Okay, these are all required, blah, blah, blah. So then we have an object that represents this link, right? Now we have a query that we are going to support. And it returns links, which is this list of objects, which currently only has one. And this part is what confuses me. We have the link object, like the link type, and then you give it a link, and it like decomposes the content or destructures the content. Is that how this works? This just seems strange to me. But I'm sure we'll figure it out. Let's walk through the numbered comments again. Okay, they numbered it conveniently, so let's stick to that. By the way, let me know if this is too small or too big, or I'm not loud enough or something like that. Hey, Plug Panther. Okay. The links variable is used to store links at runtime. For now, everything is stored only in memory rather than being persistent in the database. That's fine. Number 2, that's this. You're adding a new resolver for the feed root field. Feed root field, which was actually they don't have. Okay. Notice that a resolver always has to be named exactly after the corresponding field from the schema definition. You're adding 3 more resolvers for the fields on the link type from the schema definition. We'll discuss what the parent argument that's passed into the resolver here is in a bit. Okay. That's kind of what I'm curious about. Go ahead and test the implementation by restarting the server. If you said your browser, expand the documentation. Okay, so let's kill this and try. Saying to check out the docs. Okay, so there's the documentation, right? So that this one didn't change. And then feed. Cool. It's kind of neat that this is all auto-generated. Oh, cool. Then it gives you the raw definitions here. Nice. Okay. So we are calling the feed query, and we want the ID, URL, and description back. Nice. I just want to screw with this for a sec. Like, what happens if I take this out? It should just return. I mean, you're saying that it has a description, but it doesn't. So it should just be null there, right? Ooh. Oh, because it's required, right? It's required. So if I take out this, which is the exclamation mark on description, and now restart this, this should work. There you go. Interesting. Just undo. But you can also do, like, you just take that out if you don't want it, right? From the client perspective. That's the interesting thing. We're like talking about 2 different perspectives here. This is from like the client perspective, and here's from the server perspective, right? All right, nice. Everything's looking good so far. The server responds with the data you defined in links. It did, right? I don't think I actually ran it with all of them. Nice, it's got autocomplete too. Perfect. Feel free to play around with the query by removing any fields from the selection set and observe the responses sent by the server. Let's now quickly talk about how a GraphQL server actually resolves the incoming queries. Yes, this is what I want to know. As you already saw, a GraphQL query consists of a number of fields that have their source in the type definitions of the GraphQL schema. That have their source in the type definitions. Let's consider the following query from above again. Yeah. All 4 fields specified in the query, feed, ID, URL, and description, can also be found inside the schema definition. That's true. Feed, query. And these are the types of the link, or the fields of the link. Now you've also learned that every field inside the schema definition is backed by one resolver function whose responsibility it is to return the data for precisely that field. Can you imagine what the query resolution process looks like now? Effectively, all the GraphQL server has to do is invoke all resolver functions for the fields that are contained in the query and then package up the response according to the query shape. Query resolution thus merely becomes a process of orchestrating the invocation of resolver functions. One thing that's still a bit weird in the implementation right now is that right now are the resolvers for the link type that all seem to follow a very simple and trivial pattern. Yeah, that's true. It's important to note that every GraphQL resolver function actually receives 4 input arguments, as the remaining 3 are not needed in our scenario right now. We're simply omitting them. Don't worry, you'll get to know them soon. So they mean like arguments here, I think. All right. First argument, called parent or sometimes root, is the result of the previous resolver execution level. Yes, what does that mean? As you already saw, GraphQL queries can be nested. Each level of nesting, i.e. nested curly braces, corresponds to one resolver execution level. The above query therefore has 2 of these execution levels. So it's got a queries for feed, that's one level, and this is the second level. Okay. I want to look at this again. Query called feed, which returns links. It's just like very different mental model to think of this compared to a traditional REST API. So I'm like trying to take it all in right now. Then you define query here, and then it returns the object that you specify. But this is dynamic, right? So you're probably going to want to put a function in there at some point to call a database or whatever. Oh, I see what's happening. So links is being returned from here. Oh, God. Sorry. Links is being resolved by feed, and then the fields of the link are being resolved by these functions here. Okay. I think that makes sense. Oh, we read that. We read that. We read that. Read that. Okay. On the first level, it invokes the feed resolver and returns the entire data stored in the links. So that query invokes this, which returns this, which is this. For the second execution level, the GraphQL server is smart enough to invoke the resolvers of the link type. Huh. That's interesting. So with any given type, it knows how to extract the field out. And I assume that you can do like some clever transformations here and stuff before it gets sent back to the client. It knows that feed returns a list of link elements for each linked element inside the list that was returned on the previous resolver level. Therefore, in all of the 3 link resolvers, the incoming parent object is the element inside the links list. Check out this article. In any case, because the implementation of the link resolvers is trivial, you can actually omit them and the server will work. We just wanted you to understand what's happening under the hood. Okay. Wait, so are they saying that I can take this out and it'll still work? Fine. Can I do this? Does that work? Does this make no sense? I just want to see what parent is. Ah, it does work. So you can see like the actual object now. So if you see what I did there, I just like added an extra line there within the resolver itself. So you can see like where, like we're going to call functions here eventually, right? Probably. I mean, I don't know like how this is used yet to speak intelligently. Let's see if there's any questions. Big up, man. All the best. Hey, man. Bezjin. Queries are for getting information. Mutations are for updating, posting, and delete. Hope it helps. Yeah, I figured that part out. Thanks, Bezjin. And if you're just getting started learning this, I have a tutorial where I went through like the first part of the documentation. So now we're actually like doing it. So it's a little bit more interesting. How are GraphQL queries resolved? By invoking all available resolver functions, by invoking the resolver function of the root field, by invoking the resolver functions for the fields contained. Whoa. Isn't it this? Oh, no. It's got to be this. Yeah. Whew. In this section, you'll learn how to add a mutation to the GraphQL API. The mutation will allow you to post new links to the server. Yay. Okay, so we're actually going to create data now. Like before, you need to start by adding the new operation to your GraphQL schema definition. In index.js, extend the type def string as follows. Okay. So let's do that. Mutation, post URL string, description string, and this returns a link. So what does this do? So takes in a URL string, takes in a description, and returns a instance of a link. So I guess the ID gets auto-generated then by us. Looks like it. At this point, the schema definition has already grown to be quite large. Let's refactor the app a bit. Oh, thank God. Okay. Create a new file inside the source directory and call it. Yes. Next, copy the entire schema definition to the new file. Whoa. Better. Can I get rid of this stuff now? Still the same. Oh, I see how it works now. So that's how it knows to read the other file. Got it. So we can get rid of that. And down here now, we say, oh, I need file system. Const fs require fs. Const path require path. Hey, what's up? Coffee? For me? Oh, nice, yeah. Thank you. Oh. Is it tea? Oh, it's cinnamon tea. Thanks. Cinnamon tea. Okay, what was I doing? Oh yeah, so we're changing the import here. And what are we doing? fs.read file sync path.join. Wow, this is, I might just copy this. Schema.graphql That's it. Constructor is that type defs can be provided either directly as a string, as you previously did, or by referencing a file that contains your schema definition. That's what you're doing now. You know, I want to keep this handy for later. I don't want to put it in here though. Let me just create a new like text file real quick. And how did I have it? It was like, yeah, it was this. This is what I want. Handy way to define GraphQL schema inline. Good. Close that up for later. Okay, so we have all this copied over now with that new file in place. You can clean up, which we have done. One convenient thing about the constructor of the GraphQL server is that type defs can be provided either directly as a string. Okay, we just saw that. Okay, so what are we doing here? Next, update the resolvers function to look as follows. So we're adding something called ID count links.length. So that's this thing's length. That's still there. That's still there. Mutation. Did we remove this? Oh, I think we did say we don't need it, right? But I'm just going to comment that out because I want to come back to it. Okay, so we're adding mutation now. Interesting. So this is where it gets fun. Post parent age. Okay, I'm gonna have to look closely at what they're doing here, but ID is equal to link dash count plus plus. Oh, so this is like their ID thing that they're using. And since this is not stored anywhere, it's just maintained on the server, it's just incrementing by 1 every time. That's fine. So every time when a mutation happens, it's updating this global variable here. Let's add the rest. Description. args.description. Where's args coming from here? Oh yeah, it's right there. Oh, age. No, that's not right. Link. Wait. What? Oh, it's hot. So parent args is what's being passed in. I don't get the difference between these, but I suppose it'll tell us in a second. URL args URL. And then we're doing another thing where we're just this confused me, like the parent and args thing. Because before I have my headphones on. We had parent and args looks like it's coming from the caller. That's the thing that was passed in. And this is like the object that we're going to be, I don't know. What are they saying here? First off, note that you're entirely removing the link resolvers as explained below. Yeah, so I just commented those out. They are not needed because the GraphQL server infers what they look like. Also, here's what's going on with the numbered comments. Number 1, you're adding a new integer variable that simply serves as a very rudimentary way to generate unique IDs for the newly created link elements. That's what this is. This thing. Okay. The implementation of the post resolver first creates a new link object, then adds it to the existing links list, and finally returns the new link. That's obvious, but like, what is going on here? Now's a good time to discuss the second argument that's passed into all resolver function, args. Okay. Any guesses? Carries the arguments for the operation, in this case the URL and the description of the link to be created. We didn't need it for the feed and info resolvers before because the corresponding root fields don't specify any arguments in the schema definition. Oh, now it's here. Oh, right. Because we're not passing anything in. Right? Post is different. The mutation is different because we're passing in this stuff. Oh, I see. That's why we care. We care about args in the mutation because we have input parameters. Whereas in the other ones, in info and feed, we just have return types. That's why they're not taking anything in. Okay. Go ahead and restart your server so you can test the new API operations. Here's a sample mutation that you can send. Okay. What did I break? Did I screw something up here? Oh, just when I was starting it. What cryptic error is this? It's directive defined. Everything looks right. Anyone see the error? Mutation. Do I need a comma there? That can't matter, right? Oh. This is included in the standard library, right? Oh, wait, maybe it's not. Some definition. What does that mean? Is directive defined? File name is good. Schema, GraphQL. Well, I'll just undo until where it's working. When was it working last? This is the classic debugger. It was when the links was, okay, it was working here, right? It was not working here. So what did I do? Was it when I added this? Oh yeah, okay. Maybe it was. Oh my god, I'm going so far back here. I think because it's trying to read off of my file here and something screwy with like... I don't know why this would be a problem. Maybe reading by off local because I'm in a Docker container. Okay, so this worked. So it was when I tried to do this. This is strange. Why did that happen? Let me just try one more time. I'm just going to straight copy paste everything. Okay. I'm going to keep this around actually. Oh, you know what? I forgot UTF-8. Crap. That was probably the problem. Damn it. I think it was. Oh well. Wait, so now everything's working, right? I think so. Link, ID, string, mutation. Let me just add something dumb here. Ooh. Okay, yeah. So it's definitely reading off my file now. Okay, so if you're watching this for the first time, remember to add UTF-8 here, or else you're going to get some cryptic errors that don't make any sense. Okay, so I can get rid of this now. And now let's redo what I just screwed up. So I was creating the mutation, right? So we did this already. So I'm just going to straight copy paste that. And now we're doing our mutation there. And we removed the link because this was shown to be unnecessary. And just to recap now, so we're getting the args from what's passed into the post mutation, and we're using it, and then we're just using the ID count and just incrementing it every time, and that's going to be the ID. I think that's where we stopped. Yeah, so now we're going to test it. Please, thank you. And let's try it. First of all, are we seeing the right? Nice. Okay, so we're seeing it. Cool. So it shows you the types of everything that's going to be returned. It shows you what you have to put in. Pretty neat. I like this. So we are just, whoa. All right, I don't know why it doesn't let me. There we go. So we're just passing something obvious in here. Cool. So now we get that back. So if I do this, oh, okay. Nice. So just out of curiosity, let's do this. Let's say console.log links, right? So now every time we add one, we should see a list here of all of them. So we should be, every time we click, we should see a growing list. So let's try that. Okay. So link 0. Oh, okay. So it had link 0 here. So it was 0 index. So I guess the size is kind of off by 1. But anyways, so we're seeing that it's growing every time. So now if I change this to google.com, we should get link -2 here, and then we should see a new one. Yeah, with google.com. Cool. So let's take that out. Checking questions. Maybe it's the file retype UTF-8, I'm guessing. Yes, Andrew, you were right. Little things matter. I wish it was an error that was meaningful, though. It was not. But yeah. It's nice to have a good tea on a cold winter afternoon. Okay, back here. The server response will look as follows. With every mutation you send, the ID count will increase, and the following IDs for creating links will be linked to, blah, blah, blah. That's what we saw. To verify that your mutation worked, you can send the feed query from before again. It now returns additional link that you created with this mutation. What was the feed query? This one. Oh, I thought it would like put it in. Nice. Very nice. Okay. To verify the mutation worked, you can send the feed query. We did that. Okay. However, once you kill and restart the server, you'll notice that the previously added links are now gone and you need to add them again. This is because the links are stored only in memory. Okay. The next sections will learn how to add a database to the GraphQL server in order to persist the data beyond the runtime of the server. If you want to practice implementing GraphQL resolvers a bit more, here's an optional challenge for you. Based on the current implementation, extend the GraphQL API with full CRUD functionality for the link type. In particular, implement the queries and mutations that have the following definitions. Fetch a single link by its ID. Let's try this one. Wait, what would you do here? You would just say, you iterate over them, right? And then you grab the one with the right ID if it's there. Oh, notice that it's not enforced to return. What was this called? It's called link. Takes in an ID. Link. So this one takes in things, right? And then it's how does this work again? There's a way to do this in like JavaScript that looks good. Filter array. There we go. Args dot. Is it this? What is it passing in again? No, it's passing an ID. And then, actually, you know what? I'm just going to do this the lazy way. And I is less than links. Oh, links.length. If, what are we saying here? Links ID equals args.id. Return link. No, we're returning links I. And if we get out of here, we return null. I think this is right. If not, who cares? Unexpected. What did I screw up? So I think it's like you do this, right? Wait, how do I pass in things again? Where was the mutation? Post, there it is. Oh, it's here, okay. That's what it looked like. So that's what the mutation looked like. So I assume this will be pretty similar. Oops. Wait. Oh. Link, and then we say ID, and then link -0, right? And then what do we want back? Let's say we want back the ID and description. I don't think that takes commas. What is this? Hey, cool. So now if you put 1 in there, then you get nothing back. So hopefully it makes sense what I did here. I basically just iterated over these, and then I'm checking to make sure that the ID is the same that I already have in my list. And if it does, then I return it. And if it doesn't, then I just return null. I don't know if I'm going to do the rest of them. I think I get the idea. What are these? Let's just talk about how we would do it. Update link. So we should probably store this in a map or something so we can get it by ID faster. So we're saying we're going to take in an ID. We're going to take in a URL. We're going to take in a string. And we need to change whichever one matches this ID. If not, you probably want to create one. And if you create one, return it. If you change something, then also return it. Delete is the same thing. You are just, instead of updating, you're just removing the thing with that ID. I think it's pretty clear how to do that. How far are we, by the way? Okay, we're about less than half. So we need to pick this up. Okay, we're going to skip this exercise then. What is the second argument that's passed into GraphQL Resolvers used for? carries the arguments for the incoming. There you go. We're going to set up SQLite. We're going to use Prisma to access the database. Prisma is an open source database toolkit that makes it easier for developers to reason about how their data and how they access it by providing a clean and type-safe API for submitting database queries. 3 tools: Prisma Client, Prisma Migrate. I've never used this before, so I have no idea what to expect here. In this tutorial, I'll be setting everything up from scratch, taking full advantage of these tools. Why Prisma? Basic mechanics of how GraphQL servers work under the hood and the beauty of GraphQL itself. It actually follows a few very simple rules. The statically typed schema in the GraphQL engine that resolves the queries inside the server take away the major pain points commonly dealt with in API development. In the real world applications, they can become extremely complex, especially because GraphQL queries can be nested multiple levels deep. The implementation often becomes tricky and can easily lead to performance problems. Need to take care of many additional workflows such as auth, authorization, pagination, filtering, blah, blah, blah. Prisma is focused on addressing that issue and making developers more productive when working with databases. Also means relinquishing control. Speaking of being productive and building awesome stuff, let's jump back in and continue with our Hacker News clone. Okay, let's install it. Happen. Source node link parent args. What do you not like? Oops. Weird. Next, use Prisma CLI to initialize the Prisma in the project. Let's make sure here. Okay, yeah, we got Prisma. Database has no table yet. Read blah blah. Set the provider of the data store block. Okay, I'm assuming it's gonna walk me through how to do this. So. Okay. Remember the GraphQL schema that you've been working with until now. Prisma is a schema 2. Oh god. Prisma directory that was created in the last step. Where? Oh, there it is. Open the schema.prisma and add the following code. So what is this? Oh, so these are our entities now that we're storing. Oh, okay, so this is a souped up ORM. Let's take this guy. Do I still need this? No, probably not. So let's just take a look at this really quick. Provider, so we're using SQLite. Cool that it couldn't support anything though, so we're using something local. Prisma client, and then just setting the types on this table. Data source, which is this, tells Prisma you'll be using SQLite. Generator indicates that you want to generate Prisma client. Data model, here we have written out our link as a model. Okay. It's finally time to actually create our SQLite database. In case you aren't familiar, SQLite has an in-process library that implements self-contained serverless serial configuration, blah, blah, blah. Great thing is that unlike most other SQL databases, SQLite does not have a separate server process. SQLite reads and writes directly to ordinary disk files. A complete SQL database with multiple tables is in a single disk file. Okay. From the root directory of your project, create your first migration by running the following command in your terminal. What does that mean? Oh, I think I'm two. Current command save doesn't exist in the new version of Prisma. Type init. Did I do something wrong here? Create your first migration by running the following command in your terminal. Oh wait, did I not do this? No, I did, right? Ooh, plugins. I did this. Am I using the wrong version somehow? Okay, let's try this one. Migrate dev. Prisma's migration functionality is currently in preview. When using any of the commands below, you need to explicitly opt in via the preview feature flag. Seriously? Has anyone used this before? This seems like a pain. Create a migration. Oh, it's MPX. Cannot find a schema Prisma file. Oh. env and env. I don't have an env. There we go. Okay. Ooh, thank God. So what command did I just run? It's this. I think I screwed something up with the directories and I don't know what I did there. Oh God. I just killed that. This stuff is ginormous. Okay, so we got this now, we got that. I think I need to like remove this every time I run this because it's like setting everything up. So now I need to go that. Okay, now what does the tutorial say? Boom. You get prompts asking if you'd like to create a new database. Select yes. Type init. I don't know, like hacker. What is this thing talking about? Oh crap. Type init for the name of the migration. This is gonna take a while. Oh, so it created all this stuff. Oh, cool. So just to show you like what it's actually doing. Oh, this is just the connection string. Just delete this stuff though. And I want to do it again with the right names in case that matters. Init, right? Take a look at the Prisma. We can make this smaller now. Take a look at the Prisma directory in your project's file system. You'll see there's now a /migrations directory that Prisma migrate created for you when running the above command. That's what we just looked at, right? Run the following command in your terminal. You just need to run one more command to actually execute the migration against your database. What is a migration? Like, what does that mean? A declarative data modeling. Oh, okay, okay. So the migrate is when you have your models and you want to use them now on your database, right? So to create the tables, create the links, create whatever. And that's what's going on here, right? That's what it's doing. Prisma, this is the UI, and this the client is the thing that we actually, like the ORM that we call the database with. Okay, where were we? Getting started with SQL. Yeah, so let's do this now. The current command up does not, of course. What's the new command? Did I type that exactly? Wait, what about? Preview? Oh, I think it's just this feature. Like they just changed the names now, which is kind of annoying. So unfortunately, the documentation is a bit out of date. But anyways, this is instead of up, you run this command. It seems npx prisma db push instead of up. I'm just gonna put that in my notes. And what did that even do? Actually, I don't even know. It launched the database. This thing. Boom, you now have a database with a link table. This just brings up database. npx prisma generate. Okay. I think that worked. It's as simple as that. You now have Node modules Prisma client. Do I? There it is. Just see what's inside there. I'm always curious to look at what they do. Oh my God. This is not readable. We are just going to close the door there and pretend we never went in. All right. Let's keep going. Create a new file in the source directory called script.js and add the following code. Yes, sir. All right. Something seems to have screwed up. I feel like this is going to error out, but thing is really not happy. Oh. Let's break down what's going on. So we're importing the Prisma client. We're instantiating it. We're defining an async function called main to send queries to the database. Write all your queries inside this function. Okay. Call the main function, close the database connection when the script terminates. Take a moment to retype the query line. Notice the helpful autocompletion you get after typing Prisma. Where? I didn't get that though. Why isn't that working? Oh, Primsa. There we go. Primsa client is wrong. Okay. Still pissed. I'm pretty sure this is going to fail. Oh. I think it's just like having some resolver problems. Not excluded. Okay, hold on. I'm just trying to index everything. It shouldn't be freaking out like this. I mean, if I do this over in my... Oh, it's happening everywhere. What did I do? Do I just need to like restart? Anyways, okay, so looks like autocomplete's a little bit screwed up, but everything seems to be working. I'll have to fix that later on. Take out the notes. Anyways, so this seemed to work. So there's nothing in there, right? We don't have any information in our database. Now what? You successfully queried the database with the Prisma client. Of course, we got an empty array since the database is empty. So now let's quickly create a new link in the same script. Type out the following lines of code yourself inside the main function right above the all links. Okay. Wait. Oh, above all links. Okay, new link. Wait, prisma.link. Not. Okay, so now we should have one that's created. Like, okay, this worked. I don't know what my IDE is doing here. Like, it's not able to resolve anything properly, and it's kind of annoying. Anyways, if we run this again, we should see that one entity there. There it is. Nice. Created at is null though. Why? Oh, because we're not returning it back, right? Oh, wait. Is it just like something wrong with my... Oh, it's there. It's just the font is the exact same color as my background. That's sucky. Oh well. I just need to use what's it called? What was I going to say? No, this is all right. Anyways, let's keep going. We run the commands, migrate your database. To recap, this is the typical workflow you will follow when updating your data. Manually adjust your Prisma data model. Migrate your database using Prisma Migrate. Regenerate your Prisma client. Use Prisma client in your application code to access your database. Next chapters, you evolve the API of your GraphQL server and use Prisma client to access the database. Cool. What is the role of Prisma client in the GraphQL API? It connects to your GraphQL, migrates. Let's use this one. I'll be right back in 2 minutes, guys. Where were we? Forget what we were doing with GraphQL now. You're going to learn how to connect your GraphQL server to the Prisma client. Wiring up your GraphQL schema with Prisma client. Wait, don't I need to expose these methods so that they can be called from my index? Right? At some point I will. And I need to take in arguments. Okay, I'm sure it'll get to that. The GraphQL context resolver argument. Remember how we said earlier that all GraphQL resolver functions always receive 4 arguments? To accomplish this step, you need to get to know the other one, the context argument. The context argument is plain JavaScript object that every resolver in the resolver chain can read from and write to. It basically means a means for resolvers to communicate. A really helpful feature is that you can already write to the context at the moment when the GraphQL server is being initialized. Resolver chain could read. Means for resolvers to communicate. Resolvers to communicate. Why would resolvers want to communicate? Hey, Sarah. Thanks for joining. You can already write to the context. Okay, this means that we can attach an instance of Prisma client to the context when initializing the server and then access it from our resolvers via the context argument. So this is like your global. That's a bit theoretical, so let's see how it looks like in action. First, import Prisma client into index.js. Yes, sir. Okay. Now you can attach an instance of Prisma client to the context when the GraphQL server is being initialized. In index.js, save an instance of Prisma client to a variable and update the instantiation of the GraphQL server to add to the context as follows. Okay. So we need to say const Prisma in Prisma client. And then our server. Okay. Context object that's passed into all your GraphQL resolvers is being initialized right here. And because you're attaching to an instance of Prisma client as Prisma to the GraphQL servers instantiated, you'll now be able to access context.prisma in all of your resolvers. Cool. Finally, it's time to refactor your resolvers. Type these changes yourself so that you can get used to Prisma's auto-completion. Open index.js and remove the links array entirely. Done. As well as ID count. Done. Next, you need to update the implementation of the resolver functions because they're still accessing the variables we just deleted, plus you now want to return the actual data. Okay, got it. So this was the one that I'm just going to comment this out because this was like part of the exercise and not actually part of the thing. So we're going to adjust feed now where this doesn't take any input, right? So async. This is what we had before. I'm just going to comment that out. Now we need context. New link. Okay, so this is when we get a request now for post. we need to create a new one. Context.prisma.create. Oh, link.create. I wish my autocomplete was working right now. And then you just pass in the data like normal. URL, args.url, and description, args.description. So just to recap what we're doing here, before we were just saving all this stuff to local, but now we're actually swapping stuff out with our database. So actually, I'll just delete this to make it simpler. Now what we're saying is, well, the first thing we did is we attached Prisma to the context object, which means that we are going to be able to use the Prisma client from within all of our resolvers, regardless of if it is in within our query or if it's within our mutation. You're working on a puzzle game. Can you please help me in the ending of the game? I mean, if I know the answer quickly, but I'm trying to finish this. But if I see your question and I think I can help, I'll try to answer it. So now we're adding the database concept. So we're storing this statefully. Now this is a database that just, it's stored in SQLite, so it's flat files, but it's still a database. And you can easily swap this out later if you want to use something on like RDS or, like a Postgres database that's actually on your machine or something like that. But that's what we're doing here. Oh, I forgot to return. Return a new link. Okay, so I think I understand what they're doing here. So let's run it. Okay. What do we do again? So I have a query by ID. Feed, and there's so many queries I have now. Can I like put multiple ones in here? Is that a thing? Is that gonna work? Oh, okay, yeah, there's nothing in here. Why can't I just put feed? I need to make this Vim mode. It's driving me crazy. Is there Vim mode? This is hell. I think this is the right syntax, right? Oh, but there's no one in there yet. Oh, there is. That's right. Because, wait, what? Oh, that's right. When it's fixed now, right? Because when I ran it from here, okay, so watch, like, I'm running a different file now, right? I'm going to run script.js, which is going to write to the same database, right? Okay, so now it created number 2. Now, if we open our index.js again, the fact that we just wrote this, right? We created the link here. That's written to our local file, right? So if I do this now, I get the other one as well, which is pretty close to like, a stateful database, but it's just all in flat files. Anyways, that's pretty cool. And so now we can get feed. What else can we do? We can insert, right? We can post, mutation, and we can do post. And then we can say, wait, what do these look like again? It's like this one. Oh yeah, you gotta like do it. Sorry. www.beabetterdev.com. My websites. Okay, so now I can add another one. Now there's going to be two. Right, so now if I do this again with feed, query, feed, and I want everything. URL and description. Can I run like, wonder if I highlight, I wonder if it's smart enough to know this. This and it must be all. Oh. Just clicking buttons here. Huh. That sucks. Oh well. Cool. So now you can see that all of these rows are being pulled from the database, right? And I think if you actually go in here, you can probably even see some of the flat files. No. I don't know where it's storing it, but storing it somewhere. Could be in node modules. Anyways, so this works as many times as you want, and then like, let's see, make sure something is actually being sent here. I want to see what it's actually sending over. Huh. So you can see like what it's sending here. Sending operation name. It's like this weird character return thing. And then I guess it's parsing this on the other end. I don't know what some of these things mean. Like what does variables mean? What does operation name mean? But anyways, it's interesting. It's good to look under the hood from time to time. Anyways, what else? Prisma ships with the powerful database GUI where you can interact with your Prisma different. Okay. This is one of several. Okay. Seed in action. Run the following. But I got to kill this. MPX Prisma Studio. Oh, this port isn't exposed though. I would have to expose this port. If I try to go to 5555, it's not going to work. Yeah. Oh well. So that's fine. I mean, I trust them that it's there. And it gives you a nice UI. Let's resolvers communicate. Oh. Isn't this the right answer? It carries the query arguments. That's not what context does. It lets resolvers communicate with each other. That's the right answer, no? Great AWS series on your channel. Thanks very much. I appreciate it. Which one is right then? Okay, so now we're doing subscriptions. I want to see how far we are now. Okay, we got a couple more sections. How long have I been going for here? Almost 2 hours now. That's not bad. Okay. Second, guys. Okay. Right. So real-time GraphQL subscriptions. In this section, learn how to create real-time functionality into your app by implementing GraphQL subscriptions. The goal is to implement 2 subscriptions to be exposed by your GraphQL server. Send real-time updates to subscribe clients when a new link element is created. Send real-time updates to subscribe clients when an existing link element is upvoted. What are GraphQL subscriptions? They're a feature that allows you to send data to clients when a specific event happens. They're usually implemented with WebSockets, and that setup the server maintains a steady connection to its subscribed client. This also breaks the request response cycle that were used for all previous interactions with the API. Instead, the client initially opens up a long-lived connection to the server by sending a subscription query that specifies which event it's interested in. Every time this particular event happens, the server uses the connection to push the event data to the subscribed clients. We'll be using PubSub from the Apollo server library that we have already been using for a GraphQL server to implement subscriptions to the following events. A new model is created, an existing model is updated, and an existing model is deleted. Okay, you'll do this by adding an instance of PubSub to the context, just as we added for the Prisma client, and then calling its methods to the resolvers that each handle each of the above events. Open your index.js file where we instantiate the server and add the following. Okay, let's do this. PubSub. Acquire. Spallo server? What is Spallo? Is that a typo? Okay. Maybe? Now we need to add it to the context. So, and that goes down here. Okay. Here, creating an instance of PubSub and storing it in the variable PubSub, blah, blah, blah. Okay. What is going on here? Now, in the same file, add PubSub to the context, just as you did with Prisma. What is this? I never did this part. User ID. Never had that. Wait, did I skip? No, I didn't skip anything, did I? Yeah, see, it told us to just add context Prisma. I didn't do anything else. I think it's like skipping something. I don't know what this does, but I mean, I know what it does, but just not exactly. So what are they doing? They're returning that PubSub. They're getting the user ID out of the request, or else it's null. Okay, so they're probably going to add some concept of permissioning here. Now we can access the methods. We need to implement our subscriptions from inside of resolvers via context.pubsub. All right, let's go ahead and implement the subscription that allows your clients to subscribe to newly created link elements. Just like with queries and mutations, the first step to implement a subscription is to extend your GraphQL schema definition. Open your application schema. Hi, what time is it there? It's 2:18 p.m. Subscription type. Next, go ahead and implement the resolver for the new link field. Resolvers for subscriptions are slightly different than the ones for queries and mutations. Rather than returning any data directly, they return an async iterator, which subsequently is used by the GraphQL server to push the event data to the client. Subscription resolvers are wrapped inside an object and need to be provided as the value for a subscribe field. What does that mean? So resolvers are wrapped inside an object and need to be provided as the value for a subscribe field. Okay. You also need to provide another field called resolve that actually returns the data from the data emitted by async iterator. First, create a new file called subscription.js. Oh, my God. Here's how you need to implement the subscription resolver in that new file. Okay, let's type this and understand it as we go. So way too big text, first of all. Function new link subscribe, parent args context info, return context.pubsub.async iterator new link. Okay. Const new link is equal to subscribe new link subscribe. Resolve payload. That looks right. Code seems pretty straightforward. As mentioned before, the subscription resolver is provided as the value for subscribe field. The subscription resolver so you basically just give it an object that looks like this, where you have a function that takes in the resolver and does something. I don't know what this part does though, a new link. Oh, I guess it's like publishing an event. This function is used to resolve subscriptions and push the event data. Hop over to mutations.js. Okay, I feel like this is a tutorial that was made not as part of the other ones. This was something that was done independently, because they're like talking about things that don't exist, because it never actually asked you to do it. Like, what did it just say here? Go to your subscriptions.js. It's like, okay. Okay. Pop over to mutations.js and locate your post resolver function. So that's actually in our script. Post is, no, it's not, it's an index. Post is right here. Okay. And locate your post resolver function, adding the following call to pubsub.publish. This wasn't even what we did as part of the previous step. I don't even have an async function here. I just gotta. All right. I guess we can just put it in line though. If it works. So I guess I'm. Oh, we're adding another thing now? Posted by. This isn't even in the model. Who created this tutorial? There's no mention of posted by until right now. Oh, wait. That's later. An object in here. Okay, I think I gotta like mess with this because this is not a followable tutorial on their part. Anyways, I'll try to figure it out. So posted by, I don't even know what the hell this is. Connect ID, user ID. Okay, so what seems to be happening here? Oh, user ID isn't defined, of course. This function isn't even defined. I think I can. Yeah, this whole thing's gonna fail. I don't know what they did here. Okay, we're just not gonna do this part because they didn't really set us up for success here. I'll take out all this stuff. So we're gonna keep this the same. Context, pub sub, publish. Now you can see how we pass the same string to the publish method. Something's missing here. Here's how you need to implement the subscription resolver in that file. The last thing we need to do for our subscription implementation itself is to actually call this function. But are we calling that function? We're not calling new link subscribe. Where's that? Oh, that's how it knows. Okay. Oh, it's getting new link from there. context.prisma.link.create args.url. Okay. We did that. We added subscription. All the code in place is time to test your API. You can do so by using 2 instances, tabs, or windows. Already restart the server by first killing it. Next, open 2 browser windows and navigate. Yeah. Is this just a wrong typo? Knew that would be. Someone's got to clean this up. So we need to take just I assume they just forgot something here. Oh wait, wrong command. If this doesn't work, there's something okay, there's something wrong with their tutorial here. Subscription JS 13 new link. Huh? Control.exports. This is literally exactly from their thing here. Haven't changed a thing. Oh. Okay, so then it was asking us to do some like multi-tab thing. All the code in place. So it wants us to do 2 tabs. Okay, 2 tabs. In one playground, send the following subscription. Okay, so that looks to be working. In contrast to what happens when sending queries and mutations, instead there's a loading spinner indicating that it's waiting for an event to happen. Time to trigger a subscription event. Authenticated for that. See the previous chapter. See, it wasn't even there. See I knew this was like just stolen from somewhere and not even like thought through. The hell, man. Is this even gonna work now? Hey. Hey, then this one worked. Wait, so what just happened there? So I created a subscription, right? And then it just hung, right? Nothing was happening. I'm just trying to piece together all these different files and how everything is related. So called this, like we gave this function here. So the subscription is accessible on the resolvers. And then we called it, but it didn't do anything. It just waited. And then we called post, which as a side effect published the link to the client. So does that mean like every time the client wants a new message, they need to resubscribe? Or does it stay open? You know what I mean? Oh, look, it's still going actually. Look, see? Oh. Oh, cool. Okay. This is sick. You guys seen this? Oh, let me put these side by side. Okay. So on the right, we have our subscription that's set up. So every time an event occurs, we're going to get back the payload of the subscription, like what was published. And just trying to piece this all together. And then here, we're posting data with a mutation. And then in our code, we're saying publish an event. So this thing is like a topic, by the way, when it says new link. You can name this whatever you want, it doesn't matter. We're publishing this thing to it. And it's updating all the subscribers. So like if we had another one here, so now we have 2 subscribers. Right, so now they're both going to be waiting for data. So if I update one, let's just, right, you see that popped up, and this one should pop up too. So it only gets the stuff like the most recent events. So like I can just fire this off. Right, it's going to keep on happening. And the ID gets incremented every time. Oh, doesn't support scrolling very well, clearly. But anyways, this is pretty cool. So that worked. That's cool. So it's keeping this connection open. Is this like, what kind of connection is this? Just out of curiosity. Whoa. Oh, it's opening up a WebSocket. See that? Type WebSocket. So what are you sending, mister? Okay. Neat. Pretty cool. Close that up. Close that up. Refresh that. All right. Let's keep on going. Observe the playground with this. Okay, we saw this. Adding a voting feature. The next feature to be added is a voting feature which lets users upvote certain links. The very first step here is to extend your. I don't think I want to do this. Like I think I know how this works now. To just vote. Let's just skim through this. I'm not going to actually implement it. I think we get the idea of how it works. And now we're just adding additional functionality on top, which is like good if you want to complete the circle, but I think we just want to get the broad strokes here. So we're adding some more objects now. Oh, look, this is cool. You can define relations between your data objects using Prisma. So create like foreign keys and everything. So we're creating a new schema. So he's creating a bunch of new mutations. The vote Okay. Adding more types. And what are they doing here? This is the mutation for voting. So we don't have a user ID. So it's trying to find all of the posts or all the links with this user ID. I think. Find unique vote. Link ID. Link ID is this thing. Boolean vote, already voted. Or else it's creating a vote instance. Okay. And then it's publishing out to its subscribers as well. Wow, it's really raining out there. Okay, so it's just adding more functionality here, adding votes, adding more. Vote resolver in the resolvers object, subscribing to votes. So it's just decorating on top of the things that we've already built. I don't think this needs to be repeated here. There you go. Filtering. So I'm just going to skim this one as well. Filtering and pagination. By using Prisma Client, you'll be able to implement filtering capabilities to your API without much effort. Heavy lifting of query resolution will be performed by Prisma. All you need to do is forward incoming queries to it. First step, feed query. Oh, so you're going to filter on the database side. That's basically what they're trying to do here. So this is more of a lesson on Prisma. It's just showing you how to do like filtration, which I don't really care about. Like, I'm probably not going to use this library in real life anyways, to be honest with you. But it's useful to know that, like, how ORMs exist. This one seems pretty confusing, to be honest with you. Like, what the hell is going on here, you know? Okay. Pagination. Okay, this might actually be important. Well, it's important for Prisma. Limit offset, cursor based. Again, this doesn't matter if you're not using this library, which I suggest you to do your own research and pick the right library for you. This is just basically a Prisma tutorial at this point, so we're going to skip all of this. We learned the GraphQL parts, which is the part that I cared about. Let's read the summary, and then we can wrap it up, because I'm getting tired. In this tutorial, you learned how to create a GraphQL server from scratch. The stack you're using was based on NodeJS, Apollo Server, and Prisma. Apollo Server is a fast, simple GraphQL server built on top of Express. It comes with several features, such as out-of-the-box support for GraphQL playgrounds. If you want to dive deeper, become part of the awesome GraphQL community, here are a few resources. Okay, so just to recap on everything that we did here in this tutorial. So we started with just a very simple project, and all it really did was just fetch some data from like links that were stored in memory here in the code itself. And then we added an info. Well, this one doesn't actually even do anything info, but feed gets you a list of all the available posts. And by the way, we're creating a clone of like this thing, Hacker News, something similar to this, where you have like links and posts and all that kind of stuff, right? So we had a feed query, which gets all of the records. We have a post mutation, which creates a record if it doesn't already exist. And then it publishes a notification to all the subscribers that care about whenever new posts are created. And then we create a subscription that belongs over here, that all it does is it publishes a event, a new link event, whenever someone subscribes, or whenever, actually this is just setting up the topic. Never mind. And then on subscribe, it's calling this function, and then it just returns the payload back. So for instance, if someone is subscribed to new link like this, then whenever a link gets created through the post method, then we're just going to return the body of the link. So it'll have the URL, it'll have the description, it'll have the user ID. So the person that's subscribing will get that content. So that's there's setup that's going on here. And then we learned about context and how to add Prisma and PubSub. And then we set up Prisma to have a SQLite database, and that generated a whole bunch of files that we're seeing over here. So like Prisma client, your migration files, like your actual SQL you can see here if you kind of go and play with these files that exist. But that's the idea here. I thought this was a good kind of first step into GraphQL. And I would suggest you guys to follow the same tutorial. I learned a lot. I know it's something different when you do it yourself. That's what I would suggest for you to do. But yeah, if you guys like this, let me know. Feel free to leave comments or anything. But I think that's it for now. And the next part of this, I want to create a front end with React to actually visualize it. So that's going to be the next project. And it's going to be using this tutorial on how to GraphQL. So I did this one for the server, so GraphQL Node, and I want to do this one next for React and Apollo. So that's what my next live stream is going to be. It's going to be on how to do the React and Apollo part. Anyways, hope you guys have a good day, and everyone stay safe.